Okay, so this is problem number 10 from Hall and Knight Higher Algebra, Chapter 1 Ratios. The problem is that if y over x minus z is equal to y plus x over z is equal to x over y, then we have to find ratio x is to y is to z. Now, let us label each of these ratios. Suppose we call this first ratio with label 1. We'll call this ratio 2 and the last ratio as 3. Now before we solve this problem, I want you to look at one of the properties of the ratio. This property is very important. The property is that suppose we have been given any number of ratios. It can be like if A over B is equal to C over D is equal to E over F, and we have any number of ratios with last ratio being M over N. Then suppose each of these ratio is equal to k. The property is that if you take the sum of all the numerators and if you divide it by sum of all the denominators, you will still get the same ratio. So what you will have is this ratio will also be equal to k. Now we will use this property in this problem. So suppose we add all the numerators, that is we add 1 plus 2 plus 3. So we add all the numerators, we get 2y plus 2x, and we add all the denominators. So minus z cancels and we get x plus y. We can take 2 as a common factor out, so we get 2x plus y over x plus y. Now this 2x plus y over x plus y is equal to all the individual ratios here, that is it is equal to y over x minus z, this is equal to y plus x over z, and this is also equal to x over y. Now we have two cases here. Suppose case 1 is when x plus y is not equal to 0. Okay, suppose if x plus y is not equal to 0, then we can say that x is to y is equal to, remember that this ratio is also equal to x is to y. So we can say that x is to y is equal to, because x plus y is not equal to 0, so we can cancel x plus y and x plus y from the numerator and denominator, and we get x is to y is equal to 2. So now we have found x is to y. For finding x is to y is to z, we can either find y is to z or we can either find x is to z. So we will find y is to z. So for finding y is to z, let us take equation number 2, that is let us take ratio number 2, okay, and we multiply the ratio number 2 by minus 1 in the numerator and the denominator. So what you get is, if you multiply ratio 2 with minus 1 in the numerator, you get minus 1 times y plus x over minus 1 times z. So you get minus y minus x over minus z. Now this ratio is still equal to x over y, because the ratio will not change if we multiply numerator and the denominator by minus 1. Now we will use this property again. So we add the numerator. If you add the numerator, minus x cancels, you get minus y, and you add the denominator, you get minus z plus y. This can be written as y over z minus y. Now all of these ratios is still equal to x over y, so this is also equal to 2. Now from this last equation we can find y over z. What we do is we add the numerator to the denominator, so we get y over z minus y plus y. Now if we have added numerator to the denominator, we have to do the same thing over here. So we have to add, denominator is 1, so we have to add 2 here. This y cancels, so we get y over z is equal to 2 over 3. I'm just applying, that's from here to here, I'm just applying componendo and dividendo rule. You could have easily done the cross multiplication and you would end up getting the same result. This is up to you, whichever way you want you can do it. So for the case 1, x plus y is equal to 0, we have got x is to y is equal to 2, y is to z is equal to 2 over 3. So this implies that first we'll write y is to z, this is equal to 2 over 3. Now what is x is to y? X is to y is 2. So if y is equal to 2, what should be x? X should be 4. So for the first case, what we get is x is to y is to z is equal to 4 is to 2 is to 3. Now for second case, case number 2, we have x plus y is equal to 0. This implies that x is equal to minus y, or x over y is equal to minus 1. This is also equal to y over x. Now you can see that we have a relationship between, if you check ratio number 3 and ratio number 1. If we take a reciprocal of ratio number 3, we get y over x. So you take the reciprocal of ratio number 3, you get y over x, and you take reciprocal of ratio number 1, so you get x minus z over y. So you get x minus z over y. Now you distribute this ratio, so you get x over y minus z over y. Now you see, we already know that y over x is equal to minus 1, x over y is equal to minus 1. So x over y and y over x are equal actually. So this will imply that y over x is minus 1 is equal to x over y is minus 1 minus z over y. So you will get z over y is equal to 0, and this implies that z is equal to 0. Okay, and this also implies that y is not equal to 0, x is not equal to 0. Okay, so what we get is, if x is not equal to 0, y is not equal to 0, z is not equal to 0, then x plus y is equal to 0, then x is to y is equal to minus 1. Okay, from here, and z is equal to 0. I've seen that some people writing this solution as x is to y is to z is equal to 1 is to minus 1 is to 0. I have a problem with this notation, because normally when we are using ratio, we do not employ the term 0, because this automatically implies that we are doing division by 0. So that is why I am writing it this way. It is much better to write it this way, that if your x is not equal to 0, y is not equal to 0, z is not equal to 0, but x plus y is equal to 0, then it will automatically imply that x is to y is equal to minus 1 and z is equal to 0. So this is how we should write the case 2 solution. And I think you have understood what I tried to explain in this problem. If you have any question, you just leave the comments and we are done. Thank you.